Today I'm going to talk about like botnets, the present day botnets. And this is a research that has been, we are like my team and my university, like my department has been doing for the last couple of months. And we came across some of the interesting facts and how the botnets are actually exploiting the integrity of system nowadays. And so we came across with some interesting concepts and techniques that I'm just going to present today. So this has been a collaborative research with one of my team known as like Technician Security Labs and with my advisor. And so just a little background of mine. I'm a third-year PhD candidate at Michigan State University. Present day, I'm working for like ISIC partners. And I previously worked for some other companies, and this is some of the previous biodata that I have. And Rohit is one of my great friends who has done a lot of work over this and collaborated with my advisor here. So today I just want to put a little disclaimer. The point is that like whatever the things and concepts I'm going to discuss today is totally upon my research and it does not relate to any of my employer. So it's an independent research that some of my group members are doing and I'm also doing as a part of my PhD. So today's agenda we are going to talk about like bot spreading mechanisms. Some of the things you might be on like spear phishing and kind of things like being existing for a long period of time. But at this present point of time, what are the changes that have been come in the field of malware? We're going to talk about exploit packs, try-by download frameworks, spreaders, and with some live videos. Then we're going to talk about the post-exploitation. Once your system is infected, what kind of things that a bot actually manipulates in your system and to subvert the integrity. And then we're going to talk about like data exfiltration strategies and the concept of third-generation botnets, how the various bots are actually exploiting the HTTP communication channel to exfiltrate the data out of the system. So it started with like for the present day, like last couple of years, for like 1 or 2 years, it's been started with Zeus, like one of the great botnet that came to exist. And that actually gave a birth to like third generation botnets. Why I'm mentioning here third generation is like the first generation is a typical set of botnets which actually uses the IRC protocol. So if we want to characterize these botnets, why these are third generation, second generation, and the first generation, so typically we look at two kind of things, like what kind of motivation they have, and then what kind of the perspective they have in exploiting the systems. So it started with Zeus, then it came to be SpyEye, then at present time we are looking into Andromeda, Smoke is there, NGR existed. It existed like 6 months ago, still going fine, but not that much. The place has been taken by Andromeda and Smoke, and the upcoming, which is actually building nowadays, called as a UPass bot. So most of like why hybrid? Because some of the botnets are actually, getting properties or characteristics of other botnets. Typically, for example, like SpyEye actually harness the power of Zeus in getting the web injects concept. And then there's like an NGR, which is also using a similar kind of thing. And then it's like a very good statistic produced by the Microsoft, while like the third generation botnets infections all around the world. So if you look specifically, it gives you an idea how the Zeus bot is started impacting the North America. And that actually gives you an idea, like this is just only a one part of the world. And you can expect the infections that occur on the global level. But this works pretty fine. It gives like things have changed in the world of botnets with an advent of third generation, which typically exploits HTTP protocol, and the motivation is all about exploiting the online banking to get the money or like a shortcut to success, whatever we say. So the artifact which I want to lay stress here is like the devil is present in the details, and we know that. And if we don't know the details, we don't know the crux of the concept, it's not pretty worthwhile to spend time, and we will not be able to build the defenses. And so we have to do a little offense to get the defense, to build the defense according to that. But we need to get to the details, the crux of the concepts. And let's talk about the bot spreading mechanisms that are widely deployed nowadays. Some of these concepts have been known for a while, but with the change of a lot of technologies, with the passage of time, things have changed. The design, the architecture, the framework, how the botnets are exploiting, it has changed a bit. Let's take a look. I want to start with like browser exploit packs. Last year we presented like a complete details of like black hole and how it infects, and a lot of details in like virus bulletin conference. But still, if you remember, within the last year, if you've gone through a lot of media articles and things like that. Even at this present point of time, black hole exploit pack is really running fast. And it's still exploiting the things at a very large scale. So what it actually means, typically, I mean, if you remember, I say a Metasploit browser autopwn module is built on the same design. I mean, you have to collect and bundle a lot of exploits together. And then what it works like, host it as in a web application somewhere on the malicious domain. So what it works like, your browser sends up a request, it fingerprints it, and then gets what kind of vulnerable versions you are running of plugins and other components. And then it exploits according to that. It fingerprinted, okay, you got a vulnerable version of PDF, you got a vulnerable version of Adobe, Flash, Silverlight, and things like that. Okay, serve that exploit, which has been known. And if you see in the present time, Java is the most plugin. Java is mostly exploited nowadays because it gives you an easy access. It's a platform independent stuff, and so it gives you a heavy access to that. So what works? It's an automated frameworks, the browser exploit packs, and as I stated, exploits are bundled together. So mostly, if you see, they're it's mostly written in PHP and MySQL. Yeah, it's an open, independent code structure. You can construct whatever you want and then build the codes. I remember correctly, last year we was analyzing Phoenix exploit pack. So it was actually using a direct exploit from the Metasploit, which was written in Ruby. So it's like being a cross-platform independent. They can plug in into each other and then can serve the exploit and things like that. And they implement some sort of techniques like if a particular machine is sending a request to a command and control server that is hosting a browser exploit pack on the same domain. And it typically fingerprints your browser and fingerprints your IP address and sees, okay, we got a one request from this IP address. We don't want to serve malware to them. So you get a one IP per system. So malware is served to per IP basis. And then talk about custom JavaScripts are there which are used explicitly for fingerprinting. It gives me the browser version, give me the user environment information, and this is very much required for the browser exploit packs. And so whatever the example that I'm going to discuss in this talk is totally on the real-time case studies that we have analyzed, and all these iframes and obfuscated scripts and this kind of pattern that I put on the slides here is being used heavily nowadays. I mean, it's the similar set of pattern that browser exploit packs like Black Hole, Nuclear Pack are using. And if you go and find some of the things on malware domain list, and then you find some malicious domains, and then you try to find, hey, where is a malicious iframe is there? So if you look at the construct, the kind of it is being constructed, you will get these kind of patterns. And it's really easy. You can do some dirty code tricks. You can manipulate things like alert to document.write, and then you can put alert instead of evil, and things like that to actually render the script. But you can also do one more thing, you can do it tactically, step by step, and try to understand how the code actually manipulates. And this actually gives you an idea, and that actually obfuscated code, when we de-obfuscate it, it gets into this iframe. And it is this iframe is actually rendered dynamically in the code. That gives you an idea how the browser exploit packs are getting used with obfuscated iframes. And that is how the browser exploit packs actually fingerprint your browser version and the kind of plugins you're using. And these are also kind of a typical scripts. They're rendered dynamically. So what happens when you visit a malicious URL, you click it, then you've been redirected to some part, and then this code comes up which finds that, okay, this is a plugin is vulnerable. And then later on you find that the vulnerable plugin have an exploit that is being embedded in the browser exploit pack, and it serves that exploit in that case. And so before going further, I will just want to lay stress here. So we were testing something. We came across this domain which is actually hosting the nuclear exploit pack. And this is just a statistics page, and you can see that when an attacker actually exploits the heavy traffic volume website and injects a malicious iframe, and which is being pointed to the browser exploit pack, and you will see how fast the infection occurs. Let's take a look here. The idea behind showing is the concept once the high traffic volume website is exploited and we put a malicious iframe, then how the stat varies. And That's the thing is like, so this particular malicious domain is hosting a nuclear exploit pack. So when we were testing, we get an access to like the stats page. And then we typically want to look at how it is working. So a simple refresh and loading the web page again and again, keep on changing the ideas like the total and how many loads are occurring at one specific point of time. Yep. Oh, well, it's a video, so I cannot. It's like 800 by 600, actually. So this actually gives you an idea. So we keep on refreshing and seeing like how many loads are happening within seconds. And every time we try refresh, we get like it's really going fast. So the infections are really going fast. And that actually gives us an idea how fast this thing is, and when you do it in an automated manner. And the exploited domain was like all my videos.net and the all respective domains which were actually got infected. And every user that went to that domain, accessed some videos and things like that, keep on getting infecting and getting the bots. But that was an actually case study of like how the nuclear exploit pack is triggering up the things. So still black hole exists, but nuclear packs are still raging high. Now we're going to talk a little about like drive-by download attacks. It's a technique that has been existing for a long period of time, but it's still going pretty fine, and it's still very robust in understanding and exploiting the browsers. Typically, it's just in a redirection scenario. The user browser is redirected to the malicious domain, it fingerprints it, and the idea is like it's really hard for a user to notice this attack. It's not that easy for the user to, there's a drive-by download happening in the system, and user can notice that. It's really difficult, I would say, for the user to do that. And that's how it actually works. So whenever the user visits a malicious domain, a typical browser is like fingerprinted, and then actually the browser exploit pack actually serves the exploit, which is actually using like JavaScript heap string concept, and then exploit the browser pretty easily. And it all works in a stealth manner. So this is an last like 3 or 4 months back, this drive-by download framework came to exist. It's an automated exploit framework that is being used to serve Java-based exploits. It's known as like AnonJDB. And it works pretty fine. I mean, you got a vulnerable version of Java, and there's an all exploit lined up. It gets obfuscated, and that's being served to the users on that part. So you can see like automated drive-by download frameworks are still existing at a large scale, and that works pretty fine. Let's take a look at the black hole exploit pack in action. It's like a complete attack scenario that gives you an idea that how the things work. The only thing that I cannot show here in this particular video is like we cannot show explicitly where the drive-by download is happening, but you will get an idea when it happens and how the things work. For example, very simple scenario of like spear phishing here. So we try to log in into our email account, and then we'll see we get some like phishing email. So let's say we get this email, and there is a compressed URL. So what happened in this particular case? I think one second. Hello?
If you ask leading questions like that, you can kind of see the wheels turning, and they say like stuff like that.
Okay, so if you realize here, like this particular web page has this compressed obfuscated iframe in it, which is just really hard to deobfuscate in that sense. But the another way we can do is like we can perform the behavioral analysis. So what we did actually, we actually used a simple HTTP Fox plugin here. And that actually gives you an idea, like how many hops the requests are going through. So well, actually, I designed like it's like 800 and 600, but I think it's like it's not. Anyways, so if you get an idea here, so what is happening here? So when the user clicks on that particular request, it keeps on hopping different IPs, and it's not like a one single IP. Like you click it, you get an exploit. No, it's keep on going from like content delivery network to the another IP, and then to the malicious domain, where it is actually hosting a browser exploit pack. That's actually show you that the browser actually started connecting to the third-party domain with different hops. So when you visited it, so this was a clean system actually. So we performed a little scan on it. That's the only way we can show that. And that's the hops that actually the browser connected previously when it accesses that link. And that's the URL. That's just got located to this IP address. And the second hop is this one. And this was actually a stats page that was like being accessed on the malicious domain, which was running like black hole exploit pack. So when we completed the scan of the system, it gives like there is a one infection in the system. And then we try to look at the results. We find that it got a signature of ZBot, which is called as an Azure spot. So this actually gives us an idea, like the black hole, like automated exploit packs are really worked in collaboration with the botnets in spreading bots, and that's how they work for. And that's what the idea is all about. And this is the obfuscated script, which was actually really compressed. And so it's really hard to deobfuscate it easily. And we had to do the behavioral analysis and get the things done. So actually, that actually gives you an idea, the whole complete life cycle of how you get a spear phishing mail is like compressed using like URL shortening service, things like that. And there are multiple hops that the user has to go through. And then it serves with the exploit. That's pretty fine. Now let's talk about spreaders. And so we were analyzing like UPass bot, which is a new upcoming breed of botnet, and it's pretty sophisticated, and they have implemented a pretty good spreader called as a USB spreader. This technique worked previously, but it's still working pretty fine, and they have implemented it really good. And we'll show you by going through this case study how we can build signature very easily. And so on your infected system, when the bot is there, it actually acts as a monitoring service. It actually creates a monitoring service which actually looks for what kind of USB you are going to insert in your system. And whenever there is any plug-and-play devices actually gets inserted in the system, it actually releases like register device notification W function, which is in a Windows inbuilt API. And that works pretty fine. So if you look at the screenshot of the disassembly I have put up there, it actually gives you an idea. The bot is actually taking up a CLS ID parameter, which actually points to the USB device. And then if you go down, it's like a registry device notification function, so which will notify there's some device has already been inserted into the system. Is somebody there? And try to give like a window messages to the system so that it gives us this active scenario. So what happened in this particular case is in the USB spreading mechanism, so a bot is usually, which is has to write a USB monitoring module. It actually creates a Windows proc, which is in a Windows inbuilt API call. And then it actually looks forward for the Windows message device change notification, which is being done by the device broadcast header. And again, it looks for like different kind of interfaces which has. So if you look on the downwards, so there is a USB device, and it has like a W-param divide, specified for the Windows processor. And it actually gives you an idea like there is a DBT device arrival. And okay, the device has actually arrived in the system. So what it is going to do, so it actually going to fetch another call in that, which is called as a unit mask, which actually is going to be a broadcast volume. So what happened in that case, once your system actually gets the notification from the USB device, like it is in there. And the bot is actually going to monitor all these things. And it will check like the plug and play device, like for example, USB, is going to get us some hardest notification letter, like it can be X, Y, Z or something like that, the volume notification or the volume number. And after getting this, it actually gets an idea, okay, now the bot actually gets an idea like the USB is actually inserted into the system. So what it does actually, it actually calls another Windows inbuilt API called a copy file W and actually creates an auto-run file in the USB. And how it actually does that, the disassembly actually gives you an idea. So it actually generates, this is an example of the UPass bot which actually gives you the point. So it actually created a WS_WS as some sort of a random executable name which is going to place in the USB. And it's also going to create an autorun.env file which is going to put up some parameters in it. So it will gives you the exe to the USB device as well as an autorun file to the USB device. And it actually sets an attributes to that. Another way of doing is like, except from auto linking, is we call this technique as a malicious .link file infections. Typically like 1 year back, Microsoft .link vulnerability is exploited the most for doing some exploitation at the system level. So simple, it's like a sort of shortcuts. The bot can also create a shortcut in that sense. And creating that one, the disassembly gives you an idea how it is doing that. And it simply places the link in that, and even it's in a bot into it. So whenever the USB is inserted into another system, it checks for the autorun file as well as the malicious link file. And then it triggers the exe file into the system, which is like spreading a bot from system to system level. And this technique works pretty fine, and it's been one of the core technique of the UPass bot. So when we connect it back to the command and control server, it gives you an idea of the USB spreading. And that actually shows you that how many USBs have been infected by the bot. And it also picks up what kind of drive letters it picks in the system and things like that. So it's like a system to system level infection. I mean, the bot has to actually enlarge, and it has to make the botnet really bigger in that sense. So it has to keep on spreading things in that way. This is a one spreader. There are many other spreaders like instant messenger spreaders, like for example, exploiting instant messaging functionality in Google Talk, MSN Messenger, and wide variety of messengers. Another one is like the latest technique has been developed recently in the NGR bot, which actually exploits the Facebook chat panel from the system. So it hooks messages that our browser actually sends and then inject malicious messages containing URL to the malicious domain. And so getting all that information, when we get a detailed information, we get an idea like, I want to build a alert signature for like the intrusion prevention system, and that's how we can easily got the information. And so using these parameters, we can build up the signature, and that's by doing a reverse engineering. And if you use that signature, you can get all the infections that UPass bot is doing. And so that actually works really well. I mean, if you go to the crux of the problem and you get the ideas and you get the information you want, and if you get that information and then you can build these signatures very easily, it's not a big task. And again, another spreading mechanism is like a social networks exploitation. I think it's been one of the best exploiting platform that has become, and the malware authors and the attackers are really exploiting it. And it's not that hard to actually trick users to click on some sort of links and things like that. So sometime back we were analyzing one case, and it came to us like it was like a case of like jacking and a click jacking. So there was a malicious website which actually doing the like jacking in social network website. And when we came across that, and it was pretty interesting technique. It was there like for like 4 or 5 months ago, I suppose, but it has been seen in the wild. So how it works? Let's take a look at it. For example, in a browser, you have opened your Facebook session, and I think many users do that and then try to do a lot of work side by side. For example, if an attacker can force a user to visit a malicious domain or some like a tricky domain, which has some sort of malicious code in it. So in this case, the user is actually logged into his Facebook account, and that is a sort of another malicious web page. So if you see exactly, you can get a like button the impression of the like button is going along with the mouse here. Because I didn't make it like transparent, I just changed the code to show it explicitly how it is actually working. And what happened in that case, it gives you an idea now. So this is a script that malicious web page is using. It is actually collaborative with the clickjacking attack. And with that clickjacking, you can hide up the buttons, you can hide up the other things on a web page, and then you can still issue the request. Let's see how it works. So when the user clicked on this malicious page, a request is being sent in the form of post parameter, and it goes to facebook.com actually. So what happened in this case, when I logged back into the account and refreshed it, and you'll see there is a like link appears called as Robin likes this link. And when user click that link, it is redirected to the malicious domain here, which is actually serving a backdoor VMware, like a VM player file, and which is actually downloading a malware onto the user system. So in order to show it like in a clear manner, I have removed some of the stealthy code out of it. That actually gives you an idea how the likejacking works. So even if you go to that malicious domain and you try to look into the source code on the client side, you won't find anything because the VM file actually is backdoored, and in it there is a malicious code which is rendering an iframe and then downloading a malware onto the user system. So this actually gives us an idea how the social networks are getting exploited. It's very simple. I mean, the user doesn't have to do. The attacker actually does not have to do anything seriously in the Facebook context, but just it has to force the users to visit some other domain which is open on the same context of the browser you are using, and then from the other tab you can simply send up the request to the Facebook that actually inserts malicious links in it. Now let's take a look at the post-exploitation strategy, like how the bots actually subvert the system integrity once it gets into your system. The very interesting technique that we monitor is like the Rust kill. It's like it came to exist from a group of warriors in Russia, and typically used in the Diablo, like anything like the Diablo game players, to actually show up the power they have while they are playing something and things like that. So the Rust kill is a pretty interesting module that is being used by bots nowadays. So what it does actually, so it actually monitors wherever the new file is downloaded into the infected machine. Like being an attacker, I actually gave a command to the bot, okay, download one particular file that is a malicious executable file from the third-party domain. It downloads it and it executes it. But after that, what Rust kill does is that it removes, once it executes that malicious file, it removes all the fingerprints of that particular file from the system to avoid detection. And it's some sort of showing up a power of a particular bot, right? It has that kind of functionality to download a third-party executable onto the infected machine, then executing it, and then completely removing all the instances that actually shows that this file has been executed on the system. So we saw that when we were analyzing NGR bot, which is like a dog bot, existed earlier, and it actually uses this technique, and it worked pretty fine. And that's what Rust kill actually did. And it's still going pretty fine in that sense. But the whole concept of showing the Rust kill is here is that how sophisticated the bots have become. I mean, previously, if you look at the design of IRC-based bots, and now the Rust kill kind of functionality, and they are getting more developed with the passage of time. So let's see. When we did some like disassembly of the Rust kill module, it will give you an idea that the Rust kill is going to detect a particular file if it has made modification in it, going to detect if there is some sort of DNS like settings have been modified in the system, and there will be like detecting some sort of registry manipulation in the system. So this is a very interesting thing, and it's a sort of like really stealth technique. And let's take a look with an example of hybrid bot. And what we did we get a sample of NGR bot. We just did some reverse engineering. We made it work in a controlled manner, and we set up our own IRC channel so that it connects back to it. Because NGR bot is a hybrid bot, and it has some sort of functionality which third generation botnets possess. So this actually gives you an idea. I connected back to the IRC channel. I just only an NGR. And in our virtual machine, there is an NGR bot here. So what are we going to do? We're going to execute this bot in our control virtual machine here. So it melts itself. So this functionality of bots is termed as melting. It's like a self-destructive code. Like you try to remove like the dropper protection it has, and so that it can install randomly somewhere in the application data using Windows inbuilt crypto API. So if you see now, the victim machine is actually get connected back to the IRC channel. So it says like can US/X piece and Windows XP machine, and there is a CAUGFEF, which is in a random name of the bot. So in order to produce this demo, what I did actually previously, I actually get a link to the PuTTY file somewhere on the internet. And I execute a command that NGR uses called as an Apaja. And when we paste up, and I started the Rustskill module with an -r option. And you see what's happened. So this file is actually get executed on the victim machine. And that actually gives you an idea. The bot actually fetched that file, execute it, and things like that. So you can execute as many times as you can. And since it's just like for this particular demo, what happens once the file is executed, after that the Rustskill will remove all the instances of that particular file, even the file itself from the system. So you got it again. So it works pretty fine in every case, every time you want to execute a third-party executable on the infected machine. And that actually gives you an idea what the Rustskill actually did in this particular demo. And I think like the big problem nowadays is like a DNS changer. I mean, so DNS changer can be an individual malware. It can be a part of some malware. Or it can be a different classification of malware we can do. But according to us, what we have analyzed, it's just a kind of functionality of a malware, how it's going to exploit the DNS settings in a system. So it works, and it has been a great problem because using this technique, it's pretty easy to actually redirect users to any place and things like that. Let's take a look. DNS changer, I mean, with this technique, you can try several different ways to actually manipulate the infected system. The very first one is to just put up an entries in somewhere in the host file. Or you can simply change you can simply change the DNS server entry with a malicious IP address. That's a very simple one. I mean, once you do that, what happened in the context of system is that changing the DNS settings won't allow the system to connect back to some of the very security websites such as Microsoft to download the updates and things like that. You can do much more with that. And that's what attackers are doing nowadays. So there are different ways one can do that. We can produce like DNS amplification attack in a small local area network where you can exploit the DNS servers directly by just manipulating the cache and things like that. Or maybe you can simply host a rogue DHCP server which actually gets your connections at first rather than the legitimate DHCP server do. And then it goes for like DNS querying and things like that. But that's fine. That's a very normal way of doing things, changing and manipulating the DNS entries. So how the bots are doing it? So bots are actually implementing the concept of hooking. And hooking DNS libraries gives them the power and gives them the really way to execute these things in a stealthy manner. What happened in that case, it works dynamically. So the bot actually hooks the DNS API provided by the Microsoft. That's very good. So there is a function, if we know correctly, like DNS query, and which is upon like imported and some sort of exported by some other DLLs called as DNS API. So we understand the concept of hooking, and there's a different way you can perform hooking. There is an import address table hooking, then you can do inline hooking. Then you could do a DLL injection, creating remote thread. Then you can do like set Windows hook. And there's other ways like you can create create remote thread function and different way of performing hooking. But what is the stealth way is like inline hooking, where the actually bot, the malware authors, when they write a bot, and they actually implement a concept of deter and trampoline functions, and that actually redirect the flow of these functions like DNS query, and then it redirects you to the hook module. And it all happens dynamically. And that's what the real crux of this DNS changer is like, things like that. Another way of doing the hooking is you can exploit the DNS cache resolver service and try to check whether the send to function has been hooked or not. And these two things, even implemented by the conflicker virus too, but it's still going fine. Latest breed of botnets are also using it. And how they are doing it, let's take a look. And when we disassemble the bot and we get an idea how they are doing it, and this is the functionality being provided by NGR bot. So it can block the request, it can redirect the DNS request, and do certain things like that. And how it does that, let's take a look. So in this particular demo, we are still going to connect to the IRC channel, and then we are going to throw away some of the commands like change DNS commands, and then we'll see how it dynamically hooks the DNS API libraries and block the certain set of websites in the context of infected system. We're still connecting back to the NGR, and if you see clearly here, the bot is still there. It means the system is alive and it's activated. In order to show that, let's just open some websites like Microsoft and Facebook.com to see whether the connection is alive and the websites are opening pretty fine or not. So at this point of time, we are able to open Microsoft.com, and then we are able to open Facebook.com. That's fine. So we close the browser. And then I get back to the IRC channel, and I issued a command that is being written in NGR bot doing the change DNS. And then I did for the Microsoft.com, it blocked it. And I again did it for like Facebook.com. So now that's the user, like for example, user gets back onto the system, try to open some website, for example, Microsoft. So it gets blocked. Again, the Facebook actually gets blocked. So it happens because of the NGR bot actually implemented the concept of DNS hooking. It's not exactly like it is manipulating the host file or doing some sort of other things like that, but it actually implemented hooking. And that actually gives you a dynamically binding at the runtime environment. So we did another different test. Sometimes DNS manipulation really go awry in some sense, and that is the example here. So when we redirect Google to some malware domain, and the system is giving up like no found, and then you still look at the URL, it's just a mismanaged DNS query, but this actually gives you an idea like DNS manipulation still works pretty fine in the infected system. Like these kind of designs really hamper the security context of a system. Now we have gone through like a lot of things. We take a look at like how the nuclear exploit pack is working. We had a look at like how the black hole exploit pack is working. Then we look at some of the techniques like Rustkill, and then we looked at DNS exploitation in the infected systems. Now here comes is like how to exploit browsers. Like once your system is infected, okay, that's fine. I got an access to your system, but I'm not anymore interested in it. Like the bots are actually designed to exfiltrate data out of the system. And with the third generation botnets, HTTP is the protocol, what they are actually doing it. And in order to do that, just a very simple things, most of the malware actually implement these things like try to manipulate the zone entries in the Internet Explorer, and then manipulating Firefox entries by configuring some parameters in the user.js file. The only idea is like they are doing it, they just try to remove all the HTTP level notifications. I mean, for example, over the SSL, they want to remove all those kind of notifications. And they force the browser to send a data over HTTP channel, rather HTTPS. Because sometimes browser gives you a warning, okay, the channel is being changed from HTTP to HTTPS. So in order to remove all those sort of notification, bot actually manipulates the user.js file. And this is one of the interesting technique that been existing for a couple of months now. And this is actually another replica of like man in the middle. The only problem or the only differentiation is that it actually works inside a system and man in the middle works between two endpoints in the network. So the bot which is actually get installed is a userland rootkit actually. Because the browser process is run in a userland system, and the bot has to work on the userland level to actually hook some kind of functions inside it. So this diagram actually gives you an idea when a user actually accesses a legitimate web page, and when the web page is sent back to the user machine in the form of HTTP response, the bot actually hooks that response and try to inject something into it. And then it actually sends up the manipulated web page back to the user. User feels that like this is a legitimate page. There's nothing like that because the content works in line. And user provides all sort of information, sensitive information, and things like that. And then it is being sent back to the server. But again, going back to the server, the request is again hooked by the bot. And the bot actually redirects back into the command and control server, picking up all the information in the post request. And that is actually a concept of man in the browser. The MITB agent actually sits inside a system, and whatever the communication the browser has with the endpoint, it actually monitors it and try to manipulate it accordingly. Let's take a look at this example. I'm not sure, but if you go to the chase.com bank website nowadays and you try to look at like types of online fraud, and you will get this explicit image out there, and they put that in like virus and malware sample kind of thing. And they have a lot of details written for it, like it's just because of your system is infected, we can't do anything. But actually this is an example of web injects. This is an example of MITB attack. And how it works, let's take a look at it. Okay, as I stated earlier, it's a technique known as web injects. I mean, since the bot is inside your system, it can do many things accordingly. And whenever user sends a request, gets a response, and before the response actually gets rendered in the browser, the bot actually injects some malicious scripts into it. We'll take a look at some of the attacks that have been conducted against Citibank and how they wrote that particular web inject construct. But this actually gives a lot of power to the bot to manipulate the online banking and to manipulate a lot of functionality of the web pages in the client side. But this is a really interesting technique, and we haven't found any good defense since our team is working over it, and let's see if we can come up with some defense for web injects or not. And that is actually gives you an idea how the example look like. So that is a set URL, data before, data inject, and data end is like a parameters in the web injects file. It actually used to construct a one rule. So if you look at the set URI parameter there, so it is being defined, so the attacker has to define a URL there. So any bankofamerica.com, and then there are flags like G, P, and H, which actually gives like, for this particular URL, if a machine or a browser sends a request, whether it's a GET request, whether it's a POST request, or whether it's any H request, so there's a lot of, there is an explanation out there for L and H. But typically it is against GET and POST request. And then you will tell that in a particular web page, I want to inject this kind of data before this tag. And what kind of data I want to inject and what kind of content has to be go on after that. So this is a real-time web injects, and this attack was conducted against Citibank. It's like a forceful cookie injection. And so the bot actually injects all that code in the web page. And if you see on the data before, it is being data before tag, so there is a branding.js file. So that code will remain there, and the bot will actually inject the code after that, and then put up a script tag at the end. So this payload actually looks inline to the user. I mean, user is not going to look at the JavaScript code, but this will get executed in the inline when a user accesses a Citibank website. Let's take another example. This one is for the like a bankofamerica.com, again for all get and post requests. So in this particular web inject, the bot actually injects an ATM input type to actually extract the ATM numbers. And again, it works inline. And if you look at the sample example downwards, it again was like against Wells Fargo. So we got this like web inject sample somewhere when we were testing something, and that infected machine has all these samples. And so any user on that particular infected machine, if it's going to open these websites like Bank of America, Wells Fargo, the bot is going to inject this kind of code in the web pages. And how it looks like, it's a very stealthy and inline. So in this case, like web injects is a very interesting technique on that part. Let's take a look at the form grabbing. It's an it's an advanced level technique, but it works very well with the present day botnets. How it works, like so some of the bots are not very much interested in getting a key log, like a logging information, because it produces a lot of like garbage data and things like that. They have become more sophisticated. So what they are doing, like they are hooking the browser inbuilt DLLs and then try to hook certain functions inside it. And once they hook the functions, they extract all the information out of it. And the form grabbing is the one of that technique. So in form grabbing, whenever you submit anything, like you put your credentials, you put anything like social security number, account number, credit card numbers, and you try to submit the information back to the server, the bot actually hooks that information. That's why the technique is known as form grabbing. And when it does that, so this shot has taken I have taken it from the internet, but it was like a pretty good explanation of the form grabbing as well as like web injects. So with the web injects, you can inject like an illegitimate input box somewhere, which actually asks you some sort of your PIN number, your ATM number, and things like that. And when you submit that information, the bot inside the infected system hooks that thing and sends it back to the command and control server. And how the harvested data looks like, it gives you an idea right here. And this is the whole set of information you actually get from the infected machine using form grabbing. And this was an example that we were testing, and we get an idea like from the infected machine, there was an Kaspersky antivirus license key entered by the user, and it was retrieved on the command and control server. And in order to show that how it works, this is the last demo that I have. And we constructed this using iSpot, which is actually considered as a descendant of Zeus because it's using a lot of source code from the Zeus in order to work. So again, we are going to execute this malicious bot. So when we do that, it again implements the concept of melting. And we try to refresh it, the bot actually goes away because it has to destruct the dropper. And so considering this skin, you'll get what an IP address of the infected machine is. And we are logging back into the command and control server, a controlled one that we use for testing. So this is just like a very simple interface of the iSpot. And what I'm doing, I'm just trying to get all the list of bots that are connected back to the command and control server here. And if you go down, this is the system that we have. And if you map up the IP address, this IP address maps to this one. So it means like the infected machine is connected back to the command and control server. And the bot has really taken control of that system. So that's fine. So what we are going to do, let's say the user is going to open a chase.com website. It opens here. I'm not using the real-time credentials or things like that. I'm just using the wrong credentials here, but just try to show that how this technique works. And we're also opening like a facebook.com to just try to show that this technique not only works on the banking websites, but a lot on the other social network websites too. So I just put any password. and I submitted it. So both requests goes through the infected system. The system is, so when we get back to the command and control panel and look at the reports, so if you go down, then you get like there's a request has been logged from the chase.com. And let's see what we have. This actually gives you all the information about the bot. But if you go down, you actually get the whole of the post request here. So you have a user ID, you have a password, and you have a lot of other information. So if you are providing an account information, doing a transaction, and then you're all gone. So the similar thing works with the Facebook. So actually the bot implements a bit of delay in actually picking up, in actually grabbing the request from the client side. And so when we submitted it again, and we get back to the command and control panel and search for the things, and you get a request from the Facebook too. And that actually picks up all the credentials from the client side on the infected machine. So it's a pretty good technique, and it's working pretty fine. So you get all the information in the post requests in the command and control panel. And what you look like, this data is not yours. Once it is being extracted from the system, it's not yours, and it has been sold into the underground market and a lot of things like that. So the conclusion is that looking at this kind of scenario, the kind of techniques that we have discussed here, the botnets have become more robust and sophisticated. There is a significant increase in the exploitation of browsers. Browsers provide a window to the internet, so it's always good to exploit them. HTTP has been used as a preferable protocol for data exfiltration. And at the end, I would like to say botnets die hard, and they are still existing, and they're going to exist. But just the thing that we have to do, we had to come up with a new protection mechanism that uses the concept of asymmetry. If we can spot or if we can stop these botnets for some period of time, then we can still done with a lot of things. So any questions? Yep.
Excellent research. I know for a fact that AV companies, security researchers have access to C2 panels, expo panels, for research purposes and reporting. My question is, when do you see a day when companies such as yours technically destroy the botnets using your access to the C2 panels?
Actually, yeah. So he actually, if I got it correctly, so he actually asked so we are using command and control panels and things for doing research purposes, but when it's going to be companies like ours or the research labs, some of the small groups that we are doing, so when they are going to bust these command and control panels and to remove these botnets out of the system, again, I mean, actually, if you ask me on this part, these botnets are actually exploit the default design of technology, basically. So when we analyze something, we try to implement a concept of infiltration, because if we don't know what a technique like Rustkill does, we are not able to build the defense mechanisms. Getting onto your part, previously we found some bugs in SpyEye command and control panel where you can use that bugs to actually gain access to the CNC, because these guys are not very much interested in building a secure command and control panel to some extent. For them, it's all about selling and purchasing of data and extracting the things. And it depends on a lot of things. When you're doing research, you might have some gain access to the samples, then you can deploy and then see how things are working. And again, it's the problem of, I won't say it's a problem, but it's a choice. What kind of defense mechanisms you want to work? You want to go and bust the command and control panel, so you want to go ahead and then build defense mechanism on the system side, or building a secure browsers and things like that.
wrong mic.
I'm looking for a play in the industry where smart companies can analyze threats and safely, based on their expertise, deploy botnets safely without putting grab on or hospitals.
Yeah, that's interesting.
So you can continue the question and answers over at Q&A for room number 3. And that's it.
Yep. Thanks, everyone. Sorry about that.
I'm kind of glad I gave you an extra 5 minutes. But it just looks like you needed it.